We've explored the data. Before we train a single model, we have to build honest ground to stand on. That means two things: a fair way to measure a model, and a baseline score it has to beat. Here's the trap. Suppose we grow a deep, flexible model and grade it on the same data it trained on. It scores a perfect 100%. But it didn't learn, it memorized. Show it new applicants it has never seen, and it drops to just 77%. A score on the training data is a lie. To trust a number, we must measure it on data the model has never touched. So the very first move, before anything else, is to split the data. We keep 400 of our 500 applicants to learn from, the training set. And we set the other 100 aside as a test set, unseen final exam questions. But we don't split at random. We stratify. We make sure the rare class is represented the same way on both sides. Our overall default rate is 23%, so the training set gets 92 defaulters out of 400, and the test set gets 23 out of 100. Both halves are 23%, just like the whole. Now the most important rule of the whole project: we seal the test set. It goes in a vault. We do not look at it. We do not tune on it. We do not peek. We open it exactly once, at the very end, in Lesson 8. Every decision from here on uses only the training data. The moment the test set influences a choice, it stops being an honest final exam. Now for the second piece, the baseline. Imagine a model scores 81% accuracy. Is that good? You genuinely cannot say, not without something to compare it against. A number alone is meaningless. A baseline is the reference that turns it into a verdict. So let's build the dumbest possible model. It doesn't learn anything at all. It just always predicts the most common answer: repaid. Since 77% of our applicants did repay, this lazy rule is right 77% of the time. On paper, that looks strong. But look closer. By always saying repaid, this model catches 0 of the 115 defaulters. Not one. Its ability to rank risk is no better than a coin flip, an AUC of exactly 0.5. And by approving everyone, it loses the full $575,000. 77% accuracy, and useless. This is exactly why, back in Lesson 2, we threw accuracy out. Now a smarter baseline. A simple logistic regression. Nothing fancy. The plain model we've already met. We grade it honestly, by holding out slices of the training data and averaging, never touching the sealed test set. That gives an AUC of about 0.76. Well above the coin flip, and it actually catches defaulters. So here are our two baselines, side by side. The do-nothing majority model at 0.5. The simple logistic model at 0.76. That 0.76 is now the line to beat. In Lesson 6, every fancier model, trees, forests, nearest neighbors, has to clear this bar to earn its place. If it can't beat the simple model, its complexity isn't worth it. That's the honest baseline. Split the data, stratify to keep the classes balanced, and seal the test set in a vault. Then set two baselines, the majority class floor at 0.5, and a simple model at 0.76 that real candidates must beat. But those models can't read our raw data yet. Different scales, categories, gaps. Next, we build the pre-processing pipeline that gets it model ready.